Hi everyone, today we'll be solving the problem D marking which came in Atcoder Beginner Contest 290. First we'll be discussing the problem statement, then we will be discussing the approach, and finally we'll see the implementation in C++ language. However, if you understand the concept, you can apply this in any particular language. Also, the problem is pretty mathematical and so is the problem statement. So in case you are willing to read it, then please pause the video and do so. However, I'll be trying to break the things down as much as I can. So let's get started. So we are given n squares. So let's suppose that n is 6 and we are given a displacement which is d. So for this problem, let's say that it is 4 for now. And we start by marking the square at the position number 0. So we'll also have something called turn, which in question is given as k. And we'll have to say the mark tile. The mark tile. So in the first turn, we mark the tile number 0. And this 0 will now become our A, right? So mark tile is going to be A, just the previous time that we marked. So this becomes our A. Now what we do is that we move the displacement times forward. That means we mark 0. Now we go ahead and mark the fourth square. So in turn 2, we mark the square that is numbered 4. The next time we are going to move in a circular fashion. So it's better to visualize this in a circular way. So I have drawn this thing into a circular fashion. Now the circle is not perfect, but bear with me. So we had already marked the tiles numbered 0 and 4, and we are moving in the clockwise direction, and each time we will move 4 steps. So we marked 4 as for the last time. So this time we will be landing on 5, 0, 1 and 2. So this time we will land on number 2. So in third iteration, we mark the tile number 2. Then we go ahead and move 4 steps in the clockwise direction and land on number 0. Now this time we have already marked the tile 0, so we will have an increment. So we will iteratively move towards right until we find a unmarked tile, until we find a tile that is not marked, and then we will simply continue this procedure. So luckily in this case we have the immediately next tile that is 1 and it is unmarked, so we'll mark 1 this time. So tile number 1 gets marked in the fourth iteration, and then we are going to repeat this process. That means we're going to move 4 times in the clockwise direction and we'll land on number 5. So in the fifth term, we mark the tile number 5, and finally we will land on tile number 3, and that will be the tile that is marked last. So in problem we are given n, that is the number of squares, d the displacement that we move each and every time, and finally we are given k, and k is the turn. So for example, if k is equal to 3, then we'll have to output 2. Then our output will be 2 because that is the number of tile marked in that turn. So in case you haven't already tried this problem, then I would highly recommend you guys to go ahead and try this problem. However, if you want to continue further without trying, it's fine with me. Let's go. So the first extremely important thing in this question is that the constraints are very high for n, k and d. That means looping is out of the question. So in case you are extremely brilliant and you can boil down the problem to something less than equal to log n time, only then think of applying a loop. Otherwise, math is our only option to go with. Hence, our first observation becomes is that use math is our only option. The second observation is that we need to find the effective step. Now, what do I mean by an effective step? Let's suppose you go to a park which is circular, and let's suppose its circumference is 400 meter. And let's say this is the entry point. And you tell your friend that you moved in clockwise direction, let's suppose 600 meters. Then if your friend is intelligent enough, he can simply figure it out that you will be just at a distance of 200 meters towards this direction from the starting point. So this is exactly what I mean by the effective step here. In case our displacement is greater than n, so we'll be exactly moving d modulus n times. So even if d is less than n, we can simply apply this thing to be safe. So d modulus equal to n will be our effective step in this case. The third most important observation of this question is that we will have to think in cyclic manner. Now, what do I mean by cyclic manner? Now, in order to understand this one, we need to visualize it a bit more. So we started by marking the tile number 0, then we marked 4, then we mark 2, and then we again mark 0. So the first very important observation is that we will always complete our cycle at the square number 0. Why so? So because let's assume that this is not true and we can complete our cycle at any damn number. So let's suppose I say that I need to land at 5 in order to complete this cycle. Now this is obviously sounding very very foolish because we never encountered 5 and the cycle cannot be completed over here. So the options left are 4, 2. So let's say that we need to come on the tile number 4 so that we can complete our cycle. But wait, we need to first encounter 0 only, then we can land at tile number 4 because that's the displacement. Similarly, for 2, we can say that we'll first have to land on tile number 4, and for that, the prerequisite is to land at tile number 0. Hence, we can say that we'll always complete our cycle at the square number 0. The next observation will be that once we have completed a cycle, it will contribute to a +1 step. That is because once we have encountered 0, then we'll simply go towards the tile number 1 and it will be definitely unmarked. In case you are wondering that, okay, what if d is equal to 1? Well, in that case, we do not complete any cycle and we will simply mark the number in linear fashion. However, even if the displacement is equal to 2, then we can be sure that 1 will be definitely unmarked. So let's understand this by taking the similar example. Once we reach the tile number 0, it contributes a +1, and then we will repeat the exact same cycle just with the displacement of 1. So this means that we'll be marking 1 and the next of 4 and the next of 2 in this particular cycle. So now in order to solve this problem, we need to answer two very very important questions. The first one is that how many tiles or how many squares do we mark in one cycle? And the second very very important question is that how many cycles um, before the kth turn, before kth mark. So to answer the second question, if we know that the first question has the answer, let's suppose that these are the number of steps in that particular cycle, then we can simply say that k by number of steps. So k by number of steps will be the number of cycles, and then the remaining steps will be simply k modulus steps. That means the length of the cycle. Now, how do we calculate these steps? So for this particular problem, we can again take the park analogy. So let's suppose there are two people, A and B. A takes the step of size n every time, and B takes a step of d every time. Now n is equal to the circumference of this circle, and d can be equal or cannot be equal. It doesn't matter. So to understand, we will simply say that d is less than n for now, because we can obviously take the modulus with n. So we know that after the distance of LCM of n and d, these two will meet again. So this is a pretty standard problem, and I will not be discussing how this came, but we know that after a distance of LCM of their steps, they will meet. So how many steps would we have taken till now? So that's LCM of n comma d. Let's suppose this is equal to L upon the step size. So d. So these will be the number of steps that we would have taken till now. Now we also know that LCM into GCD is equal to the product of the two numbers, that's n and d. So we are interested in finding L upon d, which will be simply equal to n upon g. That means GCD of d and n. So these are the number of steps. So that's all that we need to solve this problem. Let's hop on to the code. So the code is pretty small. We simply take the input of n, d, and k. Now this can be pretty easily visualized that we are moving one step ahead from our turn. So we can subtract 1 from k. Now d modulus n, just in case d is greater than n. And so I don't even know if this is necessary or not, but it's just better to be safe. Then we can simply calculate the steps as I already explained. The number of cycles will be simply k divided by the steps, and the remaining steps that we need to take is definitely the remainder of the cycle size and the number of steps that we have to take in total. Now we can simply print the cycles plus the remaining steps into d distance, because for each and every step we are moving d distance forward, and we can simply take the modulus by n. Now, in case you have any further queries, then feel free to drop a comment down below. If you like this video, then do give it a thumbs up and please subscribe to my channel for more such content. Thank you.